Welcome all of you to the 11th lecture of the subject Digital Electronics. In this lecture, we will be dealing about logic gates. We will be having a definition of what is logic gates, where logic gates are used, and how a logic table can be represented using a truth table. And we will start with AND gate. So coming to gates, so we will use another color. Let's use gates. Yeah, gates. Okay. For logic gates. What is logic gates? Logic gates are the basic building blocks of a digital system. Suppose if you are considering gate as a black box or a block, it will have certain inputs. Some inputs will be there for the gate, and it can have output. It can have only one output per gate. See, these inputs will have different values. That too in the logic of 0 and 1. For example, if I am taking say a 5 volt supply, if I am taking voltages above 2.5 volt as logic 1 and what is less than 2.5 volt as logic 0, then this gate will give the output depending on the threshold values of the input. Okay, that means suppose I am giving here 5 volt, say I am giving here 3 volt, here I am having 1 volt. Here the logic is 1, 1 and 0. Similarly, if I am supplying 2.5 volt, 3 volt, or 2.8 volt, 3 volt and 1 volt, then the logic is 1, 1 and 0. Okay, that is how the logic gate is built upon. Okay, the output is also in the form of logic 0 or 1. So this logic 0 or 1 depends on the maximum value of input. What is coming in. Okay. So that is a black box picture of a gate. Now, if you need to build a digital system, you need to have combination of gates. You need to have different combination of gates. That is, you may have one gate, say gate number 1 here, gate 2, say gate 3. Okay. And you can have any number of inputs. Say one input going into gate 1, another input going into gate 3, another input going into both. Okay, it can come like this. Okay, these are inputs. Here you will get some. Say I am having say gate 2 inputs to gate 2, and you will get output. So here what I am doing is I am interconnecting gate 1, gate 2 and gate 3 in a logical pattern. That is why how to design this combination, how to design this combination depending on the requirement. That forms the logic design part. So what we can say is that logic design is basically forming a logical pattern of a digital circuit. Forming a logical pattern of a digital element or of a digital circuit is known as logic design. Hope you have understood what is meant by logic design. Now, another definition or another part which is coming in truth table is coming in gate is truth table. This truth table. So what is basically a truth table? Truth table is a table which comprises of state of the input and state of the output. Now, let me give an example. Say I am having a gate with two inputs, or a logic design, having a logic design with two inputs. Say input number 1 and input number 2. Okay, so this is output. Okay, so I can make the state is logic 0 or logic 1. This logic 0 I can write it as L, and logic 1 I can write it as high. L stands for low and H stands for high. Okay, so if input 1 is low and input 2 is low, I can make the output as high. One option is there. Another option is if both are high, I can make it as low. Again, if one is low and one is high, I can make it as high. Again, if one is high and one is low, I can make it as high. Okay, so here what happens? This is basically a form of a gate. Okay, this is how you are representing a truth table. So here the first left side columns are inputs and the extreme right gives the output. Hope you have understood what is the concept of a truth table. Now let me so in this lecture what we have done is we have started with an introduction to logic gate. So what is a gate? Gate is basically a black box, or it is basically a black box which is having inputs of logic 0 and logic 1, which is based on some threshold level. Okay, so here I have mentioned the 2.5 volt, so I am taking that as the threshold level. So if I am having a gate as a black box, then depending on the inputs to the gate, I will generate the output based on the logic which is embedded in the gate. The output can be 0 or 1. Okay. Now, the combination of these gates, or a logical combination of these gates to perform a certain operation, is known as logic design. How logic design is performed? It is performed based on our requirement. So that design is basically known as logic design. So from the next lecture we will be dealing with how to start with a logic design based on gates. Now, for the gate, the inevitable element of a gate is truth table. What is truth table? It comprises of the state of the input and state of the inputs and state of the outputs. Okay. See, here input can be logic 0 or logic 1. Similarly, output also can be logic 0 or logic 1. If I am giving some example, you can like input 1 and input 2, low, low, output becomes high, 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 low, low, high, 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 low, high. Or this same thing I can write in another form using zeros and ones, like input 1, input 2, output. So write it as 0, 0, 1, 1, 1, 0, 1, this 0, 1, 1. 1, 0, 1. Okay, this is another logic. Okay, sorry, this is another truth table. So both are said to be truth tables, but only difference is in the representation. Here the representation is based on high and low. Here it is based on the logic bit. It is logic 0 or logic 1. Okay, so with that I am stopping here with an introduction to gate. So in the next lecture, we'll be dealing with AND gate, OR gate, and NOT gate. Okay, these are the basic gates. Okay, so thank you. Meet you in the next lecture.